Hi again, intermediate algebra students. You're stuck with me again now this chapter, and we're going to get started on 6-1 slope. This should be something you're somewhat familiar with, so this will be a brief online lesson. As you can see, here's the definition of slope, a measure of the steepness of the line. And one thing we want to get straight right away is what's the difference between a positive slope, a negative slope, and so on. Anytime a line slopes upward, like this first one here, we say that that has a positive slope. Positive slope. And of course that means that one that slopes downward, like the next one, will have a negative slope. And the two most confusing ones then are, what about a vertical line and what about a horizontal line? Well, a horizontal line might be the one to start with here. Obviously, if you're a downhill skier, you would not want to go skiing on something like that, downhill wise anyway. So we say that a horizontal line has a zero slope. And we'll be able to justify that when we review the definition here in a bit. And that means that a vertical line then, we say, has an undefined slope. Undefined. Sometimes we used to say, and it would still be correct, I suppose, to say this, that a vertical line has no slope, but no slope and a zero slope are different. So from left to right, if it goes up, positive slope, left to right goes down, negative, undefined slope, and zero. On our slide, here are several definitions or ways of finding the slope of a line, and you've probably heard all these before. This letter M is kind of the universal letter we use to represent slope. I'm not quite sure where that came from, but M, whenever you see that, will represent slope. Then here's our delta again. We've talked about this a little bit. The Greek letter delta means change in. So we would read this definition as the change in y over the change in x. So the vertical change first in the numerator, horizontal change in the denominator. Here's another one you've probably seen before. If we have 2 points, and these points would be x1, y1, and x2, y2, those would be two ordered pairs. You can also find the slope by subtracting them. Y2 minus y1 over x2 minus x1. And finally, the kind of the layman's definition of slope in words, rise over run. Rise would be your vertical change, run would be your horizontal change. So let's actually take some slopes here. So here's a pretty good example. First of all, can you find the slope of the line that passes through the points -5, 3, and 2, 1? First of all, let's plot these 2 points. -5, 3 is going to be right about here, or thereabouts, and 2, 1 right about here. So we want to take a look and see if we can find the slope that connects those. Well, right away you can tell that, and I'm going to just try to draw that line through here like this. Certainly this is going to be a line that has a negative slope. We can tell by how that line slants. And if you wanted to, I'll get a different color here, you could sort of connect these up into a little triangle here if you wanted. That might help you out, because then we might remember that my change in y over my change in x, and really I just have to count points here. It looks like my change in y as I count from here to here is just going to be 1, 2, 3, right? Going from positive, or excuse me, it's only going to be 2, going from +1 to +3. So my change in y is only going to be 2. My change in x, again, I could count that. Looks like from -5 to +2, if I count that, that's going to be 7. So my slope's going to be 2/7, but then once again I remember that it has to be negative, so I'm going to tack on that negative sign like that, -2/7. Now if you wanted to use that other definition of y2 minus y1 over x2 minus x1, you could do that. So let's look at that. So let's look at my 2 points. I'm going to say that this is my this one here is my x2, y2, x1, y1. So if I did that y2 minus y1 over x2 minus x1. By the way, it is important that this order stays like that. So in this case it would be 1 minus 3. Those are the two y values in my ordered pairs. And in my x's then, and I have to go in this order, 2 minus negative 5. If you switch orders in how you do that, you won't get the right answer. So 1 minus 3 is negative 2, and 2 minus a negative 5, remember if you subtract a negative, that is going to be like adding a positive, right? And so you really do end up with 2 plus 5, which is 7. Sure enough, you get the same thing each way. When we do these in class, I'll kind of emphasize more of the visual or mental approach almost in finding the slope between 2 points. This is a fairly challenging type problem here that we'll go over here, and we'll also practice in class somewhat. So I have the point negative 2, 4. So that is for sure on the graph. And then R5. So I don't know what, by R, I don't know what that is, but I do know that it's going to be on the y value of 5. So I'm just going to kind of draw a dashed line here, like that. And I know it has a slope of negative 1/5. Negative 1/5. Well, a slope of negative 1/5 again is going to slope down like this. I'm trying to figure out what would that x value be. And there's kind of a nice visual way of doing that. Really, I can count, if I know the slope is negative 1/5, that means I can count up 1 and over 5 to the left. So up 1, 1, 2, 3, 4, 5. It looks like it's going to be right here. And so it looks like that the x-coordinate of that looks to be negative 7. And so I would say then that r equals negative 7. Now there is kind of an algebraic way of approaching this one. I can show you what that is really quick. We know again that our slope is change in y over change in x. So I could write that, or y2 minus y1, I could write it as 5 minus 4. That's my two y values. And then r minus negative 2, that's my two x values that we see there. And I know that that has to equal negative 1/5. So really I end up with a little proportion here. It would be 1 over r plus 2 equals negative 1/5, like that. Now I could do a little cross multiplying, which you may remember. And if I do that, I'm going to get negative 1 times r plus 2 equals 5. When I have a negative 1 on the outside there, that's going to be negative r minus 2 equals 5. Right? I'm going to add 2 to each side. Running out of room here a little bit. And I'm going to get negative r equals 7. Well, if negative r equals 7, that means that positive r must be negative 7, like I came up with when I did it graphing wise. So that's just an algebraic approach to do that. I would almost say the visual way is a little bit easier. We'll practice on ones like these in class as well. Here's a little cartoon that helps you remember a little bit about slope. And especially as a track coach, I enjoy this one. You have to rise before you can run. Alright, thanks for watching everybody, and we'll see you guys in class. Bye.